For this video, our topic is inter-VLAN routing. By default, only hosts that are member of same VLAN can communicate. For example, this switch have two VLANs. This is VLAN 1, this is VLAN 2. This VLAN have two hosts. This VLAN also have two hosts. It means this VLAN have different network or different network ID, and this VLAN also have different network and different network ID. By default, this PC or LAN VLAN 1's PC cannot communicate with VLAN 2 PCs and vice versa. But if we want to communicate between these two VLANs, we use a router in between. We create a router. This router is connected with the trunk port. As you know, trunk send all VLANs data. It means this trunk send all VLANs data to this particular port of router, and routers receives first network's data and send it to different network, because router does routing. It means router can communicate between two different networks. Here is the scenario is like that. This is a router. This router is connected with a switch. This is VLAN 1. This is VLAN 2. This VLAN 1 is act like different LAN. This VLAN 2 is act like different LAN. So here we are using router to communicate between two different LANs. We need to create this trunk port because only trunk port can send or receive multiple VLANs data, and router need to access both VLANs data, so we need to send VLANs 1's data to router also and VLAN 2's data to router also. So we use here trunk port. So now the practical part of for this is I'm using a router here. This is my switch. These are my PCs. This is my VLAN 1 and this is my VLAN 2. Now I'm connecting these all devices. This is switch FA0 by 1 port, this is FA0 by 2, this is FA0 by 3, this is FA0 by 4, and this is FA05. It means FA0 by 5 becomes trunk. Now go to your CLI mode of switch. Now this is my network like 172.160.10.0/25. I'm using 25 CIDR. For this I'm using 172.168.10.0 10.128/25. I'm using this particular network. Here I'm going to introduce the new feature of router here. Router having an interface that is F is 0 by 0. I'm divided this interface into two parts. For example, this is router having an interface that is F is 0 by 0. I'm virtually divided this interface into two parts. This half part is belongs to vlan 1. This half part is belongs to vlan 2. It means this half part name is F is 0 by 0 dot 1 and this half part's name is FA 0 by 0 dot 2. By this way you can virtually divide the router's interface. For this interface, or you can say for this virtual interface, you need to give IP address of the VLAN 1's range, and for this virtual interface you need to give IP address of VLAN 2's range. So now first we are giving the IP addresses to the PCs. I'm giving IP address like 172.168.10.1. Default gateway is 172.168.10.100. Because I'm giving 100 for this interface, this virtual interface. IP address for this is 172.16.10.2, 172.16.10.100. This is my default gateway for this LAN. .172.168. I'm giving the wrong subnet mask for this. Subnet mask becomes 255.128. Here also the subnet mask becomes 255.128. Now for this PC, one 172.168.10.129, the IP address becomes 255.128. Default gateway 172.168.10.254. I'm giving 254 as a default gateway. I'm giving IP address 254 for this virtual interface that belongs to this VLAN. Now for this PC, 172.168.10.130, subnet mask 255.128. Default gateway is 172.168.10.254. Now go to your switch CLI mode. Go to enable mode, then configuration mode. Go to interface FA 0 by 5. Now put the command switch port mode trunk. Now go to interface, range FA 0 by 1 to 2, switch port mode access, switch port access VLAN 1, exit, create VLAN 2, go to interface, range, FA 0 by 3 to 0 by 4, 3 to 4, because these two interfaces are belongs to VLAN 1, these two interfaces are belongs to VLAN 2. I create VLAN 2 here, and now I'm using FA0 by 3 to 4. It means these two ports, and now I'm accessing switch port access VLAN 2. Now the configuration is done for this port is made trunk. These two ports are part of VLAN 1. These two ports are part of VLAN 2. For checking, you can see here show VLAN. You can see these two are part of VLAN 1. These two are part of VLAN 2. You can check here. Now the router configuration. Go to your CLI mode of router. This is your FA0 by 0. Go to your configuration mode. Interface FA0 by 0. Give an IP address like I'm giving IP address like 192.168.10.1 255.255.255.0. You can give any IP address here because I am not virtually dividing right now. Now I am dividing. Go to interface. Now I am dividing this particular interface into two virtual interfaces. FA 0 by 0.1. Press enter. You can find here the sub interface. This is configuration of sub interface. I am entering into sub interface. Now I am giving in IP address that belongs to VLAN 1. IP address 172.168.10.100 because I am giving 100 as a gateway, and the subnet mask is 255.255.255.128. Here is the problem. Configuring IP routing on a LAN sub interface is only allowed if that sub interface is already configured as part of IEEE 802.10 or IEEE 802.1q, because in inter-VLAN we are using 802.1q. So here the first command we need to give, that is encapsulation.1q. This is encapsulation.1q. Now we need to give the VLAN ID. For this interface, this is the .1 interface, FA0x0.1 interface. .1 interfaces belongs to VLAN 1, so I am giving the VLAN ID 1. Now we can give IP address here. Do the same for the next sub interface, that is interface FA0x0.2. Now we need to first give encapsulation command, that is encapsulation .1q for VLAN 2. Now we can give IP address here. IP address is 172.16.10.254 because 254 is my default gateway, so I need to give 254 here. And the subnet mask this is done on your router. Now we can check this. This is fail because of the ARP. This is fail because let's check the problem. Open your router, just giving show IP interface brief. Do show IP interface brief. Now this is a problem. Here I am giving 178. Instead of 178, I need to give 16. So go to your interface FA 0x0.1, then give the IP address 172.16.10.100 255.255.255.128. You do not give no shut command for each sub interface because we no shut the whole physical interface. After giving the no shut command for physical interface, there is no need to give command for sub interfaces. So now I think the problem is solved. Show IP interface brief 192.168.10. Now this is problem is solved. Now you can check these VLANs are, these PCs are related to same VLAN, they are successfully pinging. But if we are going to different VLAN, then they are successfully pinging. You can check here. This is PC7 to PC10. First packet is dropped just because of R. Now you want to check the process. You go to here. This is the simulation. Now send a packet from here to here. Just press auto capture. This packet goes here. Now from there this packet goes to router's 0x0.1 interface, and it forwarded to 0x0.2 interface to this trunk port. This trunk port received that particular packet and sent to relevant VLAN. The process is done by this. Now discuss about the process of it. This is our router. This interface is divided into two parts, two virtual parts. This is our VLAN that is also divided into two virtual parts. This is physical media This is trunk port that are capable to share information that related to VLAN 1 also and VLAN 2 also. This is VLAN 1 species. This is VLAN 2 species. VLAN 1 send a packet to this interface or send a frame to this packet to this interface. This interface switch that packet to trunk port. Now trunk port send a packet to the router and router receives packet on this virtual interface. After checking the routing table, router sends that same packet on the second virtual interface. This virtual interface sends the packet to this switch trunk port, and then this trunk port sends the data to the VLAN 2. This is the whole process of inter-VLAN routing. Inter-VLAN routing, also called routing on stick. Routing on stick. This is the whole process of routing. Inter-VLAN routing.